Hello everyone, welcome back to my game dev session of the game Free Return Trajectory. What about this? It's actually stable. And I'm happy. Because now I can have my game working as I intended. Let's go forward. Oh yeah, going forward at the top, I go down. So I need to go up at the left. Up here, so I go to the right. Yeah. I will try to get a very oval orbit up here. Oh, I accelerate in the wrong place. Okay, I need to deaccelerate at the I orbit here. Now, deaccelerate a little bit. This is not the ship. This is just a body. So deaccelerate here and accelerate in the low orbit. Okay. And I'm slingshotting the spaceship. So this is a very long orbit and is stable. If I go very close, it will also go a little bit further. So it always passes here. And it always passes outside of the screen. Okay. Let's try to get lower again. Let's try to do a circle around the moon. Let's try to get the circle around the moon. And I found what was wrong with it. Basically, it was not the rigid body's fault, of course. It was my fault. Of course it was my fault. Go down. I was reading about the systems and I found many people complaining about the physics engine, both the 2D and the 3D engine. I tried different engines because Godot allows me to have different engines. Very low and very stable. See, I don't fall, I don't go away, and I'm moving very fast. So yeah, I like it. My mistake was this is a test script, so this is all wrong. I need to rewrite this in the ship script or whatever. Today, the assignment for today is find a final solution for this. But basically, I have here the old one. The problem is was here. I don't have delta here. I'm sending the delta to the rigid. I'm sending the number without the delta for the rigid body manager, and in the rigid body manager, I was not applying the delta. The delta cannot be applied here. don't know why. Because technically it's the same place. Oh no, it's not. Because here I'm adding forces one to another, and I need to add the delta only in the final force. So what's happening here is that I'm adding a little bit of delta at each time I increment the final force, instead of adding just one delta at the final force. So this delta should be multiplied here and not in each iteration. Technically, this shouldn't be a problem if it was just one object reacting to the other, because it's just one iteration, so this should be the same, multiplying here or multiplying there, because there's only one. But somehow it doesn't work. In my new version, what I'm doing here, this is the new test version, what I'm doing here is I calculate everything, gravity forces, and I calculate the thrusters forces, and I just add the delta when I'm applying the force. And I'm also applying at this apply central force instead of apply force. Maybe this also, I can test now and see what happens. So if this is not central force, what happens? Save. We'll see if it's still working. This was not the problem, but I believe this is not the problem. But anyway, let's try just to make sure. The problem was the location of the delta. So yep, it's still stable. So the central force or the force doesn't make difference. I guess I will use the central force because it doesn't affect the rotation. And yeah, my mistake, sorry. But this is how we do it. We need to find... and how did I found this? This was a very interesting way. How did I find this? Well, basically, I was testing the gravity, and the gravity was getting out of orbit, and but it was very slow, and I was like, oh, I need to speed up the game so I can simulate this faster, so I don't have to wait 2 minutes every time I want to test. And I did a little code of lines of code that speed up the game using the engine. This is not here. I put it somewhere in one script, the game manager, I guess. Game manager. Game session, maybe. Yeah, it's here. If I press the number 1, it goes 100%. If I press the number 9, it goes 400%. And when I play this happened. This is very interesting. And this is the problem. Eventually, if I want to speed up the game, this will be a problem. If you want to speed up time because you want to go fast forward or slow motion, this will be a problem. I will speed up the game. Let's go around 2 or 3 times, so it's very stable, the orbit. Yeah, it's passing exactly at the same spot. Now I will speed up the time. That's not correct. It should go faster, but somehow the calculation of the delta, and I was reading about why changing the speed of the simulation affects the physics engine. It shouldn't affect. Yeah, the physics engine should just run faster, but it doesn't. It's like the physics engine still is working at the same speed, but because we have more frames per second, the delta is different, so the thing gets heavier. I don't know, maybe it's what's happening here. And it was on this occasion that I thought, well, maybe the problem is the delta. Maybe the problem is not the rigid body, maybe the problem is the delta. And what I did next was, okay, let's just rebuild the entire thing from scratch. And I did this PG, which is polar gravity, and I was like line by line. Well, let's start with the equation of the calculation of the thing and apply only this with very fixed numbers, with a very fixed target, not a list of objects, whatever. And the thing started working immediately, and I was like, okay, something's wrong in my script that is not wrong here. And then I eventually found, yeah, the delta was here all along in this script, but not here in the other scripts. So that's why central, it didn't work. The delta was in the wrong position. So the multiplication by the, oh, here now I'm also technically not calculating the thing here, is being calculated on another script. And this is just to centralize everything there. So everything that needs gravity sends the rigid body there, the thing is calculated there and returns here as a vector. That's it. So everything now is inside the polar gravity manager, which is here. And it has the same functions as the polar gravity bodies before. So I can add targets to the list. I can remove targets from the list in real time. And the thing is always calculated with the targets, but there's no delta here. No delta. So I have the numbers, I send the numbers here, or I ask for a calculation, and it calculates whatever it has inside and returns the force to the object that asked for this. And the delta is being eventually applied in the other place with the result. So I have here the result. Gravity force comes from that script. I send this rigid body and it calculates the gravity for this rigid body. It returns the force, and I just need to apply the force to the rigid body directly here, multiply by delta. This force applied times delta happens at the end because I need to apply the gravity, I need to apply the thrusters, eventually I need to apply the main engine or other things that can influence the objects. And because of that, I'm having this force to apply, and I will sum all the forces together before I multiply the delta. And this kind of works because I'm already using thrusters very roughly, and just getting the axis and apply the forces, and it's actually working good. So I'm happy with this solution. It's actually working. That speed up of the engine when I go fast forward is something that I saw some solutions to that, but I didn't try. I'm not worried about that at this point. It works, yes. So the problem has a solution. I will deal with that solution later. But mainly the thing is related with this project settings. If you go here on the physics 2D, you have common. You have here the ticks per second. How many times per second the physics engine works, and it's a fixed number. It's not depending on the power of your machine. So frames per second is one thing, but physics engine works the fixed pace. So the numbers are actually stable, more stable than just depending on the frame rate. So I believe I need to change this. If I want to change the solution, it was someone was telling, yeah, the solution is to change the ticks per second accordingly to the percentage of speed up or speed down. It makes sense. So if I go 4 times faster, maybe I need to calculate for so if I go 100% is 60 seconds to 100% to have the same relation, maybe I need to go 120 or 30. I don't know. I need to test. But that's not a problem for today. The assignment for today is to actually have this test solution that is actually working implemented on the other scripts. The planet, the ship, and the lander, whatever. So everything kind of works with what I had before. But I will need to change everything again. Because, or maybe not, I don't know, I can test, but this rigid body manager maybe I can just change the delta here and it solved the problem. Maybe I will try that first, and if it works, it's done. If it's not, if it doesn't work, maybe I will re-implement this rigid body manager, because I'm actually liking more the clarity of this script. It's more direct. And this, of course, I can clear this. This was the first test for the gravity. So what is happening here in the physics process directly in the rigid body of the object, which means this needs to be, in case of the ship, needs to be that script, and that script is the ship script, not the polar gravity or the rigid body manager. I need to think a little bit about it, because I separate the polar gravity from the ship in order to have independency from one to another. If I put again the polar gravity inside, I don't know, maybe, I don't know. I don't see any problem in doing that, because the polar gravity is not being calculated there. In this my new solution, I have the polar gravity manager is the thing that has the entire process of calculating the gravity, and this is independent. It doesn't care about which object it is, it just needs to receive one object to calculate the polar gravity. So it's kind of the same thing, but instead of being in another node, it's in another script above everything. Because this polar gravity manager is above everything, is always present and is always above everything. When I play the game, let's go here, play. If you look at the tree of the game, you have here the polar gravity manager. So you have the game events, the data manager, the game session. So this is what we had before, the music manager and radio manager. And now we have the polar gravity manager. And then we have the level with these objects calling that one to the calculation. So everything is being calculated there. Everything is centralized. Only it happens. So if I have 100 objects asking for the polar gravity, it goes one by one. It crosses the information with the list of all the objects, so it doesn't calculate the self attraction, and it's kind of clear, you know, kind of is a clean approach, I guess, to the solution. Now, and I can do this just to show you that this is actually working very stable. I'll put here another moon. Let's duplicate the moon just to see what happens. Second moon goes over there. Play. So now we should have a free return trajectory. If it doesn't fall on the second moon, no. It will fall on the first one. No, it's actually orbiting both moons. So, almost. Let me see if I can deaccelerate a little bit here. Okay. Yeah. I will fall now. Okay, so this is actually using both the three elements to calculate the traction. The moons are fixed, that's why they don't move. Because the starting pulse on the moon is 0, and they are actually fixed here somewhere. Is freeze, okay. But if I don't freeze the moon, let's delete the second one because they will collide immediately. If I don't freeze the moon, let's unfreeze the moon. The moon will wobble a little bit because, yeah, both objects attract each other. What's changed the force of attraction is the mass, and the moon has 1 million kilos of mass, and the ship has 100. So the relation is like, what, 10,000 more? I don't know. Like, so if you look at the moon, it kind of wobbles a little bit. It's almost impossible to see. It is like wobbling 1 pixel, but it's actually working. It's actually wobbling. If I duplicate the moon now, duplicate, they will collide because they will attract each other immediately. Yeah. Let's see what happens to the spaceship. And of course, if I put this one going down, let's try. Down is positive. Let's go. No, because it's super heavy. We should have one moon orbiting the other, or maybe not. Or maybe this number is not big enough. Yeah, the number was not big enough. So now we have the moons orbiting each other. More speed. More speed. Oh, I cannot go double of the speed. We reach a point where we are limited by how many bits we can save the numbers. So they are actually orbiting each other. They go out of the screen, of course. Let's put the other one going up with the same value. Just test. Play. Yeah, this is too much now. They are getting away of each other. Yeah, but you get the point. The things are actually working now. And sorry, my mistake. The delta was in the wrong place. Okay, they are orbiting each other. The spaceship is over there. I cannot go away. Let's put the spaceship here. Oh, there. I will try to make the spaceship orbit at least once around something. I don't know. Let's see if it returns somewhere. Oh, it's already full. Okay, let's go here and see what happens. I'm just playing. Anyway, so the assignment for today will be try to implement this polar gravity in the old scripts. Yeah, I believe it's working properly now. It goes around this one, it goes up. It will fall on this moon, or maybe not, because the other starts to attract. I don't know. Now that there is a weird relation between these objects. I don't know, maybe if this runs for 10 hours, they get a stable orbit around each other. I don't know. It's very funny. Anyway, the polar gravity, it works now. I will not delete this. I like this test. And I will try to implement that in the other scripts. So, returning to the ship script, what we have in the spaceship is the rigid body manager was the thing that talked to the ship itself. I will change that. But before I change that, let me just change the delta here and see what happens. Because if I can solve everything just changing the delta, so this delta disappears from here and goes there, times delta. If it works just because of this, I will be very annoyed because I waste 8 hours trying to solve this. But anyway, let's see what happened in the other levels. Maybe I need to change the numbers again because I was testing stuff. And let's see on this one. Maybe the numbers are not good enough, yeah, at this point. Okay, the spaceship goes too fast away. Ship, maybe 300. I have here a lot of bugs. I don't know why. No, I guess I will not fix these problems. I will just rebuild them. Not set one instance, of course not, because I changed this script already. Yeah, I will just delete everything and start again. And welcome to game development. You reach a point where you understand what's happening, but it's a mess. You delete everything and you write again everything more clearly. So this polar gravity, delete. This rigid body manager, delete. And this ship now has a lot of errors because of that. Oh, I didn't delete the scripts. I actually want to delete the scripts. Should I delete the scripts? Because if I delete the scripts, what's happening is that the errors will appear automatically on the other script, so I know what I have to fix. So I guess I will do that, but I will not delete them because I'm not stupid. So polar gravity, let's comment the entire thing. Or maybe this was what it was working somehow. So this is garbage. Garbage. I will delete everything that is not doing anything here at this moment, at least, because eventually I will delete everything. But I want to make sure that I don't have stuff I don't need. So okay, this is the entire script. Now let's comment the entire script. Save. So polar gravity does not exist, meaning ship 1 has errors already. The other one was the rigid body manager. Let's do the same thing here. I have no block comments, so can I go to the end fast? Yes, I can. And now I have 4 errors on the ship, and this is what I need to change. So polar gravity does not exist, and I'm accessing polar gravity to do this. Nice. The other problem is the rigid body manager that is being accessed here. Just here. I don't trust this. Anyway, this will disappear because the polar gravity will be, let me just check what did I have. I can't, let me, radio manager, don't need this, game events, don't need this, rigid body manager, yes, game session, I don't need this, polar gravity manager, yes, utilities, I don't need this, gravity system, this was, this is to be deleted. This will not, I try a solution where I have a namespace for it, but I don't like this solution, so It's kind of overcomplicating a simple thing. Polar gravity bodies, I will not need this. This is the polar gravity bodies are integrated in this new polar gravity manager. So the list and the add and remove targets is inside this polar gravity manager. So I don't need the polar gravity bodies also. Let's comment out this script. And polar gravity, it's off, polar gravity 3D off. Okay, so this is what I need to implement there. This is actually my solution, and what I'm doing in my new solution is I get the input, I get my movement, whatever. As soon as I need to apply the force, or as soon as I have all the things calculated, I apply the force by multiplying it by delta. This is the only place where delta can be multiplied. Before that, I need to sum every force that I will calculate. I don't need this print anymore. And before that, I need to have the math for each one of it. So this is actually what I need to put on the other scripts. Copy. And this goes inside the spaceship at the end of the physics process. At the end of this, I will have the last thing to do is to have that. Okay. So gravity force is the thing that comes from outside. Maybe I will not declare a variable every frame. So copy. This needs to be organized, but at this moment it just goes whatever, someplace. I need to organize these variables by groups or something. Anyway, at this point it goes to the end of the thing. So I declare gravity force, and then I will say gravity force equals to polar gravity manager. That does not exist yet. Let's create it. Well, it exists, I need to access it. So where is the ready function? It's here. Forgot the name. Come on. Polar gravity manager. Copy. Polar gravity manager. Team manager. This is the class, and the class is my other script. The variable will have the same name with small letter in the beginning. So polar gravity manager, which will substitute both of these two. Goes here. Paste, paste, paste. This one disappears. Polar gravity, undo. I delete already this one. No, let's delete this one. Let's delete both of them. And now let's delete what's wrong. So this goes away. Delete. Polar gravity stationary equals whatever. This, I will implement this later. At this point, I just want to have the polar gravity working inside the ship script. So I will not deal with variables yet. A rigid body manager, set start spin rate. I also don't have spin rate yet, so let's ignore this for now. Or maybe I will not comment because I need to tackle this. So let's the error be there. Old velocity delta equals to, I don't need, because this will be inside the rigid body, so I can just access the rigid body directly. Maybe then I will have a specific place to get these numbers in the beginning of the physics process, or something like that. And then I use a variable, so I'm not reading the velocity every exit. I don't know, in the middle of the. I believe it doesn't happen in the middle of the physics process, changing onto linear velocity. But I don't know. Anyway, this is done. Next. Velocity delta is just the velocity delta. No? Oh, velocity delta was something. So let's go on the rigid body manager and let's get this velocity delta. Where is a rigid body? Velocity delta. Velocity delta is this math function over here. Copy. So velocity delta will be equal to linear velocity. Yeah, see, this is the thing. I want this linear velocity to be always the same number, and I don't want to read the rigid body every time I need the linear velocity. So I will read the linear velocity in the beginning, which is a float linear velocity. Am I using this anywhere? Oh yes, I'm using there. Okay, so linear velocity equals to linear velocity. So this is cannot implicitly convert vector 2 to float. Okay, sorry, vector 2. So linear velocity is read from the rigid body in the beginning of the physics process, and then we use this number every time we need to calculate whatever we need to calculate. So we are not reading the rigid body every time. Copy, paste. Linear velocity maybe doesn't exist anywhere else. All the linear velocity is the same thing. So all the linear velocity at the end of the physics process, we should get the old equals to linear. So at the end, the last line is old linear velocity. I don't have old linear velocity, so I need to also declare this one. Old linear velocity equals to linear velocity. Old linear velocity needs to exist for the entire script, so it needs to be declared up here. I guess the other one can also be declared here. Vector 2. Old linear velocity. Vector 2, linear velocity. And we don't declare it here. Okay. So in the beginning of the frame, we get the one from the rigid body. This is my variable. This is the rigid body's linear velocity variable, maybe. It's not a variable. and we set the linear velocity to Alt at the end of the frame. So next frame, this number was the past velocity. Okay. Let's continue. Vector to local velocity is a linear velocity rotated. So I guess I can just delete this and it's done. Same thing here. Okay, rotation degrees. Let's get rotation degrees from here. Control find rotation degrees. The rotation degrees equals to rotation degrees. Okay. I just need to go capital letter. Nice. And angular velocity probably is the same thing. Yes, it is. Yeah, but this accesses to the rigid body, I want to make them in the beginning of the frame. Because if I need to use the number again, I need to make sure it's the same number. I believe the number doesn't change in one pass of the physics process, but I prefer to make sure of it. Or maybe I keep it this way for now, and then if it doesn't work, I will change that. Let's go now. Gravity force equals input force. So thrusters force equals to input vector times input force. Why this input force does not? What's the problem here? I believe I didn't delete this. I didn't declare this input force. Input vector is where I'm pointing. Yes. And input force is like a multiplier, probably. Let's go. How much do I have here? I don't have here anything. Thrusters force, I have thrusters force, which is the vector plus input force. Oh, that's why it doesn't exist. I copy from this, and this is 1000. Okay, let's go. No, this will not be a public variable, because once the physics is set, this is just to help. Okay, so let's go 1000. Maybe I can do a constant for this instead of having the number here, but yeah, whatever. Force to apply does not exist. Of course it doesn't exist because I didn't create it. And force to apply is a vector 2. Copy. Let's go paste. Rigid body manages starts. Okay, this is the one that I will solve in the last step. So ship force equals to force direction. So this is where I apply forces, or at least where I applied forces before. So if I have fuel, I will apply forces. This makes sense. And this is where process movement. Oh, okay. Maybe I will need to change this, because this process movement happens where? is the second thing that happens. So I will not apply forces there. I need to apply forces at the end of everything. So, well, maybe this is the end of everything because it's just visuals. It doesn't affect the forces. Maybe the dead zones will affect the forces. No, the dead zones is to stop the ship if it is in the very close to the 0 speed. But yeah, this maybe can happen before the process of the movement. Yeah, I need to have another thing. I need to have the process, and then I need to have the application of the calculations, the results. So this cannot happen this way. So this line cannot be here. Apply forces, not here. And the last problem is rigid body management, linear velocity. We already have the linear velocity here, so we can just use the same linear velocity. This is to instantiate the other ship when we broke the ship. So yeah, everything looks nice. So now we have these two problems to solve. This will take some time to solve because I don't have this set up yet, and this application of the forces need to happen. Maybe I will do this differently. If fuel is greater than 0, this fuel is being declared before everything? Yes. So if fuel is greater than 0, this can happen and force direction comes from where? Process movement. Okay, calculates the direction, blah 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 blah. All the thing, and at the end, fuel consumption, fuel minimum check. And if I have fuel, I apply the torque, or at least I send the numbers to be applied. But if I don't have fuel, force direction should be 0. So where is force direction being 0? Yes, it's here. So every frame force direction is resetted to 0, and if the fuel ends, okay, if the fuel is greater than 0, I send this to the rigid body. I'm thinking if this is the best place to do this, or if I reset the fuel here, the force direction here, in case of the fuel being 0. Because another solution is to have the force direction be equals to 0 and torque equals to 0 if fuel equals to 0. So no matter the calculation is happening, if I don't have fuel, everything is resetted. And then this force direction and this torque direction is applied at the end of the frame anyway. So it will apply 0 if I don't have fuel. Where is the end of the level? It's here. Because I need to apply the gravity force and this thruster's force. This is not thruster's force. This is what's being calculated down here. So maybe I do that. I say down here on the fuel, where's the fuel? It's here. Maybe I say thruster's force equals to force direction. Thruster's force equals to force direction. Copy paste. Force direction is a float. What? Ship force, rigid body manager. Let me look at here. Ship force. Ship force was being used. But if ship force is a vector 2, I'm confused. Ship force equals to force direction. Force direction is a vector 2. So what's your problem? Thruster force is a vector 2? No? Maybe I'm using the wrong thruster force. Where is the end? Ready? It's here. Thruster's force is a vector 2. Come on, copy. Thrusters. Okay, I need to clear also this names. Thruster's force does not exist in the current context text. Yes, it doesn't, because it's being declared inside the other method. So this thruster's force needs to be declared outside of here. Copy. And here is just updated. So thruster's force equals input vector. This will not happen here. Let's declare this thruster's force somewhere here. And instead of, so this times 1000 to be the same as the other one, save. And at this point, let's delete this one. And the torque will be the same. But the torque does not affect the gravity. Ship torque, a rigid body manager, find paste. This is being applied how? Polar gravity torque. What? Why polar gravity torque exists? Exists but is 0 because nothing changed this variable. Okay, so it doesn't exist. Final torque, or maybe polar gravity torque is being accessed from the other one. Let's see. Where's the polar gravity script? Polar gravity torque. No, I'm not accessing that. Polar gravity torque, copy, paste. Yeah, I'm not changing. No, okay. Polar gravity does not affect. Hello, Rito. How are you? If you're still there. Oh, I have the comments. Sorry. Polar gravity torque does not exist, so this is not a problem. Final torque. Final torque is being applied. Yeah, applied torque is simple and direct, times 1000 also. Copy, and we just paste it I'm not sure if here, but I believe it can be there, but I would prefer to have the things together. So apply central force and apply torque. Final torque is actually torque. This torque is 0. Yes, no, it's not 0. I will do an else statement here. I don't like this solution. Well, I need this solution. I need the fuel. I need the fuel to be affecting the spaceship. Fuel consumption, minimum fuel check. So if fuel is less than 0, it stays at 0. If the fuel is different from old fuel, it signals no more fuel. So this can be used to end the level. And then if we have fuel, process movement. Yeah, I guess I can put this down there. I will do this. No. I process the fuel, but I only apply if this is cut. If I will apply here. If I have fuel at this point, I will do this. So I will apply the force. The force is already calculated. Oh, I cannot do this. I cannot do this because apply force will also apply the gravity force. Meaning, if I don't have fuel, I don't have gravity. So this apply force needs to happen no matter what. Yeah, these things needs to happen. This is the last things before we set up the old whatever. We need to set old values. In this case I only have one, but I believe I will need another one. Old fuel can also be there. Force to apply. What I need to do here, so this happens before this. What I need to calculate here is the gravity force needs to be the same, but the thrusters force, yeah, thrusters force equals force direction only if I have fuel. Yeah, this was good down there. This was good down here on the fuel consumption. Fuel consumption, thrusters force, so the one that is being applied, equals to force direction. Force direction is being calculated here. Yeah, I need to reset it there. Because if I don't have fuel, I need to put this at 0. Yeah, I need to do an else statement here. And the same thing for the torque. Torque is being calculated there. But if I don't have fuel, torque is 0. Yep. So if fuel is greater than 0, I will apply it. I guess I don't need to change torque here. Else, so if I don't have fuel, force direction is 0. I don't have force. Force direction or thruster's force equals to a new vector 2 and torque equals 0. Torque is not being used. Why? Unnecessary assignment of a value to torque. Why? I want it to be 0. So let's look at the process. Force direction is 0. Local input vector, so this will get my keys. Force direction will be my keys times thruster's force. So I will multiply my keys by 200. Next is to calculate the torque. Torque will be input rotation times thruster's rotation force, which will be 20,000. These numbers are not correct. After that, I will apply the main engine force to the local upwards direction. So if I clicking on the input of the main engine, I will do the thing to the main engine, force direction, and I will increment the force direction. So I already have some force direction. If I press the main engine, I will have more force direction. And now play the sounds here, maybe in another place, but if it works, it works. If it works, it works. It actually doesn't work, because sometimes I have that if I click too fast, it doesn't undo the sound, doesn't stop the sound. So this doesn't happen. Sometimes this doesn't happen. So we need to check this later. Next thing, fuel consumption. So we have all the movements already calculated. Let's see, if I'm thrusting, let's decrease times delta, maybe. If I go left and right, I will decrease the fuel, and up and down the same, and rotation the same, and main engine the same. This has different multipliers because different fuel rate consumptions. Okay, and then we consume the fuel for this frame, and then we go check if it's below 0, stays at 0, which we update. Oh yeah, if the fuel is different from the old fuel, it will update the number somewhere else. So probably this goes to the probably this goes to the interface. And then if fuel is greater than 0, we send the thing. Thrust force equals to force direction. So the thrust force we are going to apply, we are going to sum to the gravity, will be whatever we calculated here. And the torque is already calculated, it doesn't need to be summed with anything. So I just use it directly. And if we don't have fuel, we reset this. And we save the fuel in old fuel, and we reach the end of this method. And this method, process movement, happens before the application of the movement. So yeah, nice. Force to apply equals to the gravity force that was already calculated. So this can go down. And the thruster's force, which was already calculated on the process movement. If no more fuel, it will be 0. So gravity plus 0 is gravity only, which is okay. This disappears from here. This is not final torque, it's just torque. Why am I using final torque? Where is final torque? Does not exist. Okay, torque only. Torque only, but torque does not exist also because it's been declared down here somewhere. Torque is being declared here. So we need to declare this outside up there, copy. And we can reset torque in the beginning as we reset the force direction. So torque equals 0. So if we don't press any key, it's 0. And now we need to declare torque up there. Save. And we should have just one mistake to solve. Set start spin rate. Spin rate is there. Set start spin rate was something inside the rigid body manager. Oh, sorry. Rigid body manager, set spin rate, copy. We just apply it to the angular velocity. Okay, copy. Paste. Start spin rate, copy, paste. And I guess the ship script is functional again. Now with the proper, gravity, polar gravity. But I'm not sure. And the best way to make sure is to test it. So let's create. Let's go here on our new test scene, moon, delete, Let's add this moon to the center of the screen. And this ship, I don't want to delete this ship. Maybe I can just save as tests scene polar gravity 2. And this one I will delete this ship, and I will put my new ship, or my old ship elements, ship 2. Well, this will be a problem. Hello, I'm back. Hello, I'm back, Adam. Hello, how are you? I actually solved the problem. I have polar gravity functioning correctly. Where is the level? I will show you very quickly. So polar gravity test, it's here, play. Look. I failed to be, oh, come on. Yeah, because, okay. I will test it in a bit. Let me finish what I was doing. I need to go bigger here. Really, 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 really big. So the ship goes there. The moon needs to be bigger. Let's put the moon at the center of the world, or the center of the universe. Transform, reset. Maybe the moon is too big. Anyway, let's go 100. No, it's too small. Like that. The collider of the moon. Moon is at the center? No, center. This is position center, okay, and collision shape needs to be bigger. Okay, let's put the spaceship outside of the moon, of course. Oh, the ship lander could not be. Come on. I don't want to fix this. I don't want to fix this, so I guess I will just comment the entire script. And well, it's now fixed. Failed to build projects. Body manager could not be found. Now comes from where? From the planet, probably. Yeah, now it's from the planet. Let's comment the planet. Planet also does not exist. And the last one comes from the ship top lander. Okay, let's comment also this thing. I will only deal with these scripts when I have the main one working properly. So I need to remove this. Save. F6. Let's see. Okay, something's happening, of course. I need a camera. Okay, create child node. Camera. Camera today. Let's make the camera bigger. How can I make the camera bigger? Scale. Scale doesn't work. I need to zoom. But the zoom function here is so weird, because if I go down, the camera gets bigger, but I have a limit. Zero is the limit, so how big can the camera be? 0.02. Maybe this is too big. 0.4. Maybe this is too small. So 0.3. Let's play and see what happens. Nothing happens. Let's solve the problems now and see where the bugs are. So the first one is Polar Gravity Manager relative to ship 2. Of course it doesn't exist. But I believe I delete this. $110. I delete this line. I remove this reference. 110. What? Polar Gravity Manager does not exist. Oh, maybe it doesn't exist because it's not there yet. This is happening in the enter tree. Polar Gravity Manager exists. I'm pretty sure. Polar Gravity Manager, it's here. So it's not happening, maybe because it's not in the wrong function, not in the correct function. Okay. Oh, relative to what? Relative to node to the ship to. No, it should be on root. Okay. Get node, of course. It's not get node. What I need is Polar Gravity Manager. Get node, yes, but from root Polar Gravity Manager directly. Okay, copy, paste. Computer is always right. If it doesn't work, it's always the human's fault. Save. Impact sounds does not exist. Okay, let's see what's the problem now. Okay, impact sounds and hatch relative. But I didn't delete the hatch. And I didn't delete the impact sounds. What's happening? Ship 124 and ship 127. 124 and 127. I didn't delete these objects. Impact sounds, get node, impact sound. I'm pretty sure I didn't delete them. It's here. And the hatch is also there. So strange. Node not found. Impact sounds relative to root / node to d / ship 2. Ship 2. ship to. Or maybe I have this Truster sound player. It's not assigned. Everything is assigned here. Now I'm very confused because this doesn't make sense. Again. Node not found. Impact sounds. But the node is there. It's here. This is an audio stream player. So impact sounds, which is an audio stream player, getting node audio stream player with this name. I know the name is not correct, but the mistake is in every iteration of the name. So why this is not working? Where do I use the impact sounds? Well, let me go brute force and see what happens. Impact sounds. It will be a variable that I can set up manually. Ta-da! See, it's there. What's your problem? Same thing for the hatch. I'm declaring the hatch here. I use the hatch anywhere else? No? No. It's just to set the auto lock. Anyway, let's see if the other problem disappeared, because this does not make sense. It works here, but it doesn't work here. Strange. Very oh, wrong scene. This is so strange. I don't know why it doesn't find the export public hatch. Object now set to an instance of an object. Which object? 130. What? I put it there manually. Hatch autolock equals autolock. Well, no, it needs to work. Come on. Why is not working? Why is this not working? Because it works here. It doesn't work in that scene, but it works on this scene. And probably I don't have errors here. It's also not starting the movement. Am I moving?
Prepare for main engine burn to decelerate as you approach the station.
Probably, but it's not. It's working, but it's not working. Anyway, let's go. Ready. Object reference not set to an instance of an object. Yes, it was. I don't know why. You don't like it. 130 is saying that is not finding this thing over here. Maybe I will delete. Maybe the ship is not saved. I will put here again the object. Ship 2. This is so strange. It's not assigned. Maybe Godot is a save. Off. Oh. And save and close. Yes, save and close. Because I see one time I had a student that wasn't able to save the scene. I don't know why. Probably the computer full of virus or whatever. I don't know. Something was wrong with saving the scene. But this was not the problem here. Ship 1. It has the thrusters sound, the thrusters main engine sound, and it also has the impact sound and the hatch. When I go on the test scene 2, the ship 2 does not have these things assigned. Of course it... come on, I'm so stupid. Sometimes, I don't know. Sometimes I'm a little bit stupid. Because I'm not changing ship 2. I'm changing ship 1. What's the difference? Why do I have 2 ships? Don't remember which one is the final one. Ship 1. What's the difference? I don't know. Come on. F6. Okay. We have something. And what we have is, we don't have bugs. Which is nice. The moon collider, a little bit bigger. So, the moon weighs a lot. let's remove this acceleration from the moon. Save, and let's freeze the moon. Yeah, the moon should be moving, but it was not moving. Anyway, oh no, because I make it bigger. So maybe this number does not, whatever. Ship weights 100 and it doesn't have acceleration, but it's also not falling. It's also not falling. And it's not falling because the ship is not adding itself to the group of objects with gravity. So in the ready function, I need to get the polar gravity manager, add target, and assign this, which is the script or the object where this polar gravity is. So the ship 1, after we get the polar gravity manager, this can exist in ready, doesn't need to be on enter tree, or it can be on enter tree, who cares. In ready we will put this object in the polar gravity. Later we will need a boolean if has polar gravity. I will do it immediately before I forget. Object mass stationary, disable other drag. This does not being used. It's not being used, so I go here, paste. By default, every ship has polar gravity. Or maybe not, false. So I don't have to change all the levels. I will need to change it anyway, but who cares? Save. F6, so nothing will happen. Okay. Now if I go on the ship and I enable the has polar gravity, it should fall. Or maybe not. Polar gravity manager. Where is the polar gravity manager? It's here. So we have a reference. Okay, we need to have three things: a reference. We set up this object as belonging there. Okay, and eventually we calculate the gravity, asking the polar manager gravity for the calculations. Gravity force. I know what's happening. What's happening is that I zoomed a lot the things. So the moon is extremely big compared to the previous version. And I think the ship is moving, but it's not moving enough, fast enough, or the traction is not. I will print the position of the ship just to make sure. So let's print, let's print linear velocity. We should have numbers there. Godot print linear velocity. So if we have 0, 0, something is not working. But if we have numbers, we are moving. And we are accelerating. The problem is the moon is too big for the weight it has. And the spaceship is too light. Can I move manually? Yes, I can, very slowly, because the spaceship is giant at this point, so these numbers don't match this reality, this scale. So maybe we just need to set up numbers. Let's make the ship heavier, like 2 tons maybe. And the moon also. 9 million tons. Or 9 million kilos. Save, let's see. It's falling faster, but not fast enough. Let's make the moon even heavier. Can I add another 0? Maybe. Okay, I'm falling faster. Can I add another 0? How much zeros do I have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm falling. And I'm destroyed. So let's make the ship heavier, like for 10 tons. I don't know the weight of a spaceship. Maybe 10 tons is too much. But yeah, I don't really care about the numbers here. Yeah, it's going faster. So it starts to accelerate a little bit faster. Let's give it an impulse, like, I don't know, 10 tons of... No, 10 tons is too much. 1 ton of force in the beginning. So it should go up. Not fast enough. Maybe 10 tons of force in the beginning. I'm not sure if this is being applied. I don't like this scale. I don't like this scale. I guess this start local force is not being applied. Where is start local force? Find start local force is being applied. No, it's not. Oh, because it was applied. And object mass is also not being applied. So maybe we need to fix this. Start local force in the polar gravity script was start local force was this line of code. So vector 2 global start velocity equals to, okay, yeah, but this is okay, let's do it. Copy. Let's do it. Wrong software. Ship. Where is the ship? Paste. Okay. I believe in the thing. And mass will be equal to object mass. Save. Because at this point, ship has a mass of 101. Save. And we want to put this mass over there, which will change in each level. So object mass 1000 kilos and 1000 kilos of thrust in the beginning. Okay, let's go 10,000 kilos of weight and 20,000 kilos of force in the beginning. Play. Nothing changed. Let me see. Road, ship, and the ship disappeared. We need to be faster. Play. Remote ship. Where's the rigid body? 100. Why just 100? It's not changing the number. Oh, it changed. Yeah, I was looking at the wrong place. Yes, it changed. Okay, 10,000. So the mass is being changed, which is okay. But the initial speed is not. So global transform with canvas. Oh, come on. This needs to happen in ready. This needs to happen. Could be at this point. And of course, we're not sending this anywhere. So apply impulse. Maybe. Apply impulse in the beginning with that direction and with that force. We set up the mass. The mass maybe needs to be set up first. And then, okay, save. Let's try, see what happens. Strange behavior. I believe it's not happening. Let's go a big number here. It's not happening. No, it's happening. Very slow. I don't like the scale of this level. I really don't like the scale. It's too big. The thing is too big. But when I go on the ship and I say, oh, let's scale this down, like 20%, 0.2. Yes, I still have this problem. Node configuration warning. Size changes to the rigid body to D will be overwritten by the physics engine when running, changing the size in children collision shapes instead. So, if I want to adjust the spaceship size for the level, my actually only solution is to scale up the numbers dramatically, not scale down the object, because this will not work. F6, let's see what happens. Apparently it's working, and this is what is annoying, because apparently it's working, but it says maybe it doesn't work. I don't understand this warning. Size changes to Rishi's body will be overridden by the physics engine when running. Well, I'm actually not using the default physics engine, and maybe that's why. What does this mean? That the scale of the weight doesn't change? Or the scale of the size doesn't change? You know, because I know that this polygon is used to calculate the inertia or how the mass is being applied to this object. When I scale down, does this polygon scales down but not the weight? I don't understand exactly what the problem is when I do this. Let's scale down the moon and see what happens. So the moon is too big. I guess I will go manual. Collision shape should be smaller and the spaceship should be closer, and the camera should be like this. So now the scale is very different. Let's see how the thing behaves. It instantiates a scaled up version. Oh, come on. I guess this scales thing will not. Let's put the spaceship going up a little bit faster. Well, this is not fast enough. This is an impulse, so maybe it needs to be a bigger number, or maybe I will just multiply this number in the script. Blah 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 times 1000. I don't know what happened, but something happened. Oh, I know what's happening. What's happening is that the spaceship starts moving too fast and it destroys itself because it goes over the structural integrity. Yep, it's already in the infinite. So let's go 1000, 10,000 times 1000 will be a very big number. Not big enough. Let's go 2 more zeros. 1 million. Too much. 100,000. $200,000 or 150. This should be good enough for testing. Yes. Yes, it is. A little bit more. I want a circular. Let's go 16. F6. Let's see. I will mute the sound because we don't need the sound. Okay, so now looking at the spaceship, what we need to make sure is that the spaceship is keeping this orbit stable, so it's passing here. Oh yeah, exactly in the same spot. Very nice. Let's go. Can I rotate? No, very slowly because sorry. What I'm going to do is to multiply so torque is 1000 already, another 0, and the force applied, this is the thruster's force, comes from where? From here, times 10,000. Save. Let's see if we can move properly now. Can I rotate the spaceship? Yes, I can. Very slowly. So maybe we increment the thruster's force where they are. Thruster's force, let's go 1700. Rotation, we can go like 5 times more. 5 times more, and main engine should go like 3000. And let's play. Okay, rotate left, rotate right. Maybe rotation could be a little bit faster. Main engine. This main engine don't have any force. Or yes, we are falling. Okay, but it needs to be stronger. Main engine like 10,000, and the thruster's force will be like this was, so 5,000. Can I take off? I believe I cannot take off. Let's restart. I have here a multiplier. Thruster's rotation, main engine. No, this is fine. This is the percentage. I guess I go double with everyone, so 10,000 here. This goes 50, 100, and this goes 20. Or even more, 30,000. Ship mass. I'm not using this ship mass, I believe. Ship mass. if I'm not using this ship mass, I will delete it because I already have this. Ship mass is up here, object mass, and this is being used. Okay, save. Let's return to Godot and let's hit play and let's make sure we have something more interesting. So the thing is moving. Let me just check one thing because I have here, I changed one option here in the window. It is not viewport, it's canvas items, okay. And the zoom is not working. F6. Much better. So rotate, yes. Rotate, yes. Forward, yes. Backwards, or let's try to stop the thing. I'm out of screen. Let's start again. And now let's move with the thrusters. So let's say if I accelerate here, I'll gain altitude on the other side of the moon. Yes. And if I stop here, I will lose altitude on the other side of the moon. Yes. Now let's just descend as much as we can so we can go faster around the moon to make sure the orbit is stable. So stop here. Whoop, too much. Come on, let's start again. A little bit too much. I can go like don't touch the moon, please. I need to go faster. Oh, no, 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 no. Wrong direction. No, it is not touching, so it's not dragging. And this is fast enough so we can test if we are passing in the same place over and over again. So if I don't do anything, I should not gain altitude or lose altitude. This is a perfect system with no drag, and which I believe it's what we actually have closer to the moon, because there's no atmosphere in the moon, at least a significant atmosphere in the moon. And if we were orbiting with some altitude, no drag, and you have a stable orbit, and we are controlling the spaceship, and I'm liking the thing. Very nice. Let's try to get a elliptical orbit just by controlling the spaceship. So I will try to go to the left. So I need to accelerate here to go there. Okay, so let's go with the main engine because it's stronger. Here we go. Whoop, just a tiny bit, maybe too much to the top. Okay, now we have a elliptical orbit. Not perfectly to the left. But who cares? Just a test. Let's see if it passes again where the mouse cursor is. I believe it's working perfectly. I already tested this with the other test scene, and maybe it's not. Or maybe I accelerate after, I don't know. Let's go again. If I'm not centered, it kind of flowers around the moon. Yeah, but this is there. I must have moved the thing. Let's wait for another turn, just to make sure. And if it passes where the mouse is, we can... Yes. Very nice. It works. It actually works. Can I land on the moon with this one? Probably not. Very interesting. So the thing of the polar gravity is working. I need to fix some issues. That starting fast, it will destroy the spaceship if it's not very tough. So now it starts broken because the structural integrity is lower than the initial speed up. And this is happening because I'm detecting the acceleration or the changes in acceleration to determine if I'm impacting something with some force. Force of impact. I guess Godot doesn't have force of impact, but we can search for it. Godot rigid body 2D. Or maybe Godot doesn't have it, but I'm not using the Godot physics engine, so maybe I can access something in the box 2D engine. Anyway, force of impact. How do I get collision impact force from a rigid body? Nothing from Godot, so probably doesn't have. Probably it doesn't exist, so it's another body. Okay, let's see. Describe the project. This is a I don't see code here, so it doesn't exist. Skeleton, no skeleton. Yeah, this is the same thing. Yep. Okay, so force of impact does not exist, so we need to calculate it. But to calculate the force of impact, we cannot use the first frame. if we are calculating with the speed of the spaceship, the first frame is stopped. The second frame we do the impulse. So the next number will be a very big number, and we will detect that. And here we have the old velocity delta. This should be find replace. Old velocity delta is being used, or is not being used. So why does it break? Where does it break? We should use this old velocity delta to calculate how fast we are going compared to the previous frame. So technically we can detect an impact using that, because the number will change a lot. Structural integrity is down here. Is velocity. Oh, I'm not calculating anything, I'm just using the velocity delta, so I need to calculate the thing. Check impact. So we need to compare the old versus the new. Old velocity delta, or maybe old linear velocity, I don't know. Why do I have to? Old linear velocity. This is being used, velocity delta. Okay, to calculate the velocity delta is already the calculation. Okay, come on. Now, if old velocity delta minus velocity delta, this should get me the difference, or maybe no, velocity delta is already the difference. Why do I have an old velocity delta? Why did I put this here? So the velocity delta is already what we want. So I guess it's done. I just need to adjust the numbers. It was already here. Let's print the velocity delta so we can actually understand how much fast we are going. Play. So velocity impact 1439. So if the structural integrity is greater than this, we can start at least at this velocity. So let's go. But this is happening in which frame? First frame? I shouldn't have this number in the beginning. I shouldn't have an impact. Velocity delta. Let's print velocity delta every frame and see what happens. Or every frame or every physics process. So at the end of the physics process, velocity delta. Save. Let's ramp up the structural integrity so it doesn't break in the beginning, but we should have 0. Or very low numbers. We don't have 0 because we have a moon, and the moon is pushing the thing. If I remove the moon, copy, delete, no more moon, I should have 0. Or at least a fixed number. Yeah, 0. Okay, so let's see if the first frame is 0. Well, it's not. And this is the problem. In the first frame, it's actually happened in the second frame. So the spaceship is put it in the scene in the beginning, and it doesn't have speed, so it's 0. Why does impact is being printed if... Yeah, because check impact is always checking. Okay, let's remove this. Let's start again. First frame is 0. This is a problem. It's an annoying problem. So first frame is 0. When we put the spaceship in the scene, we have 0 velocity. Then we need to have some kind of movement because the level starts with a movement. And the spaceship gets an impulse, so it starts to get moving. And the speed goes, this is the delta, so it's the difference from the last frame. This is not actually the first frame, this is the frame 0 probably, is the ready function, I don't know. And then we start moving, so we have a lot of movement. And then in the third level, frame, because we are not accelerating or deaccelerating, we actually have 0 acceleration, so it stays 0 until I change something. I will play and I will fire the main engine. So I have 0, but if I deaccelerate, I start to get -8 or 8. Now 0 again because there's no change in speed. If I use the thruster, I have 2. Okay, so this makes sense. What I don't like is this happening in the second frame or in the second check. So this means that I cannot check the first 2 frames. Because if I check the impact in the first 2 frames, I cannot start at the level with the movement, or else this happens. And, let's go. Let's put them on again. Spaceship. If I have some kind of low spatial integrity, 100 and 1500, which maybe it will not break because what we have is 1440, so it will not break. Let's see if it breaks when it falls on the moon. Yes, it broke. 17,111. This is a very close number to the... So I want to have a lower number here. Structural integrity about 700 or 600, something like that. So as a weaker touch to the moon will break the spaceship. But if I put here 500, the spaceship starts broken immediately because second frame is too fast. So it breaks with the acceleration. So we cannot check we cannot check acceleration for the first 2 frames. How can I do that? Maybe check impact counts something and only does this if the counter is more than 2. Why not? Maybe we can set up the old, because we are calculating velocity delta is old minus new, or new minus old. So maybe we set up linear velocity and old velocity at the same time. So it starts already with a number, but we are not setting a velocity. We are setting a force, which is a different number. And why? Because velocity is in pixels per second. And I don't want to be... Oh, this will be a problem. If I go 4K and the screen has more pixels, maybe this changes? I don't know. I hope not. But this velocity, this number here is what? No, it's not pixels per second, cannot be. What number is that? You know, when I play the game, what number is this? 1439 what? 1049 is from here to here is 5000 pixels. So 2000 and yeah, it could be pixels per second. That could be pixels per second. But pixels per second in the scene, not in the render, because I'm zooming out the render to full HD. This is like 20,000 pixels wide if it was pixel perfect. So I'm scaling down to 180. Yeah, this is pixels per second in this world. So I cannot set to the speed. The structural integrity cannot be this. It doesn't make sense. Because the structural integrity will depend on the zoom of the scene. This is not the best solution. But this is the thing I already told before. I don't like this engine, this 2D engine, physics engine working with pixels, because it doesn't make sense. It should be meters, as the 3D engine works with meters and as other engines work with meters. Because pixels is just what the camera sees, cut it in tiny squares. But the physics, the simulation should have real numbers, speed, meters per second or something like that, not pixels per second. But anyway, that is a problem, but that will not be a problem, because if I maintain the same scale, so if I never zoom in or zoom out the spaceship, technically no problem. But I don't know if I like it. It's very weird. I will disable these 3D scenes here because I was testing this in 3D yesterday. No, in the previous stream, maybe, I don't know, don't remember, when I test the 3D version. So we need to disable this check for 2 frames or for 1 frame, because I believe the first print comes from the the ready, so it's before the first frame. But we are applying pulse in the first frame, in the ready function. So we have the 0 frame and the -1 frame. I don't know. Maybe the enter tree counts as something, but we are printing down here. So this is printing. The first time it prints on the physics. So the first time it prints 0, it's printing the first frame, because the printing is happening inside the physics process, not in the ready. Yeah, this is not very smooth. Anyway, let's just have a counter here, and if the counter is greater than something, I will need to, do I have some kind of counter already? Count, no. Okay, so let's count frames. Count frames equals 0. Or count frames. It's not frames because the physics process doesn't happen in real time. It's not frame by frame, but yeah, whatever. Count frames plus plus. So we increment the count frames, and if the count frames is higher than 2, we check the impact. And if the count frames is lower than 2, we count frames. So we don't need to increment this. Well, technically, what is heavier? What is more expensive? Incrementing a number? Or doing an if statement? Maybe the if statement is more complex. So we will increment the count frames, whatever. I don't like this solution. I don't like this solution, but it should work. Maybe needs to be more than 3. Because we count just 1, 0, 1, 2, may have more than 3. Let's see. So we check impact only if the count frames is higher than 3. So technically, this will be already at 0. Okay. Okay, but not okay. I don't like this solution, but is what we can do. And if I go against the moon, I will break. These parts are not in orbit because we need to change the orbit, how the things behave. Because if you remember, I changed everything. So now let's do the debris. And the debris is, I don't know where they are. A broken ship. Where is the broken ship? It's here. So the broken ship is composed by many rigid bodies. So each one will be individual, of course. And yeah, I need to make a script just for this. Broken ship, broken part. So let's create a new script called broken part. Create a new script. Broken part. Yeah, broken part. And this should inherit from rigid body. 2D. Create. This broken part goes inside of everything. So this one, this one, this one, this one, this one, this one, and the last one. Oh, I cannot add them. Yes, I can. Okay, so all of them have this broken part, and this broken part will be very similar to that PG that we have already. So what do we need? We need a reference to the polar gravity manager. Where is the broken part? Is here. Paste. We need to get that thing, and we need to add this object to the polar gravity. Copy, paste. So now the broken part is already at the list of objects that need to be influenced by the polar gravity. Gravitational constant, yes, we will need this. Starting pulse does not make sense in this, I guess. Because we already copied the speed from the original ship. So paste. Gravitational constant does not exist, of course not. Copy, paste. And now we need to do what? We don't have input. We just have the gravity. So we just have apply central force delta, copy, paste. This happens in the physics process. And force to apply, instead of force to apply, we are going to contact this polar gravity and get the calculation from there, times delta. And that's it, the thing has gravity. Let's collide with the moon and see what happens. No. Let's check the bugs. Cannot instantiate script because the associated class could not be found. Which script? Rigid body manager. Make sure the script exists and contains a class definition with a name that... What are you talking about? I destroyed the script. Rigid body manager, it's here. Oh, yes, I forgot something. I need to go to that broken ship and remove all these rigid bodies, managers, and all these polar gravities, because this does not exist anymore. And this broken ship, just to yeah, it gets all the rigid bodies and gets them moving the same direction. Okay, so wrong play. Let's go to the test scene 2, F6. The spaceship does not break in the beginning. And we still don't have polar gravity. I guess I'm not removing the ship from the polar gravity when the ship gets destroyed. No, we are not. Where is the exit tree? No exit tree. Okay. So when we remove the spaceship, we need to remove also the spaceship from the list. And we need this command here. Copy. So on entering the tree, or in this case in the ready function, if it has polar gravity, it will add itself to the polar gravity manager. But if it doesn't, it doesn't happen. Okay. On exit, when it exits the tree, so when it's destroyed, we need to do the opposite of this. Polar gravity manager, remove target, this. If it has polar gravity, because it doesn't need to attempt removing something that does not exist. Oh yes, we have polar gravity on, 4 bugs. Oh, this comes from that engine, that physics engine, the box to the area to the... Oh, let me try something. I don't want to deal with this problem, because this is not my problem. So let's remove that engine box to the engine. Let's go again with the Godot physics. Save and restart. And let's see. Well, that bug will disappear. But let's see if the polar gravity is still working properly. I guess the Godot's physics engine multiplies the things already by a lot. Let's remove 2 zeros from every number related with forces and weights and whatever. It looks like it's in the right place. And we don't have errors. Nice. Very nice. So let's remove that print. Where is the print? Well, let's not remove the print yet. I want to see the number that breaks the spaceship. 500. Okay, let's try to go. Let's try to land on the moon and see. This is actually working very well. Oh, let me try something. I will add to each debris and the trail. Copy, paste, paste, paste. This will be funny. So many lines. What? Oh no, I didn't disable the print. Okay, so let's try to collide with some force and in an angle. I don't know if I like. Yeah, it could be interesting if it's a big impact. But maybe it's a little bit boring if it's not a big impact. I don't know. Come on. I would like the parts to be in orbit, not to fall. Let's try. Last try. Let's speed up a little bit. Come on. It's so hard. Is that so hard? Broken ship. How much? 1 kilo. Yeah. Yes. Yeah, it could be interesting to see all these orbits. Where is the other one? Or 1, 2, 3, 4, 5, 6, 7. I guess we are missing 2 of them. They went too far. They will return in the future. Okay, let's try to land on the moon and see how much force I need to break the ship. Let's see if I can land with this spaceship. Too fast. 1,000. 1,000. It didn't look like 1,000. Let me test something. Let's not put speed in the beginning. 0. $1,1800 or 1890 89 80 89 1889. Let's play again. Okay. Yeah, maybe the structural integrity at 600 would be a... Yeah, we can change this number for each level depending on how the objects behave. But yes, mission accomplished. The spaceship goes around the planet in a stable orbit. Very stable. Accurate, correct. And now we can have the level of orbiting stuff. Yes, yes, yes. So next step would be to add all these physics, new physics way of dealing with the object to the planet and to the other things that I disabled, which was the planet, the ship top, the lander, ship lander. So all of this needs to deal with gravity the same way as these ones. Rigid body manager, we don't need this anymore. Broken ship, yeah, we don't need it. Polar gravity, we don't need it. Polar gravity manager, yes, we need it, probably. Or maybe not, this is actually done. We don't need to change anything here. Ship lander top, planet, ship lander. And these are the three scripts that need the implementation of this new system. The spaceship is behaving quite nice. I like the numbers. So what I'm going to do is to make these numbers the default for this object, except the start velocity. So I don't have to change these numbers over and over and over and over and over again. So I need to take notes now. Maybe I have here some paper. And what I have here is 03, the fine move. Oh, I didn't test the fine movement. But I cannot test the fine movement in this scene. So it's actually what we have there. This is the default values. So thrusters force 100, thrusters rotation 1000, engine 300, and structural integrity 600. And by the way, mass or object mass is 100. Okay. Now let's make this the default values. Whoop, whoop, whoop. So thrust force 100, 1000, main engine 300, and structural integrity 600. Save. What? 20,000? I save this, yes. Save. Am I using ship 1? Yes, I am. What? Why is not getting the correct numbers from the script? Yeah, maybe I need to remove this the script and put it again. I don't want to do that. Well, thrusters force 100, 1000, 300, and 600. Save. So in here should be default. Okay. Yep, it's done. I will quickly try to do the things in this. I don't want to do this right now. It's too much things. Well, technically, this is exactly the same script. I didn't change anything. Ship lander. Well, I did add that release button. Input. Separation. I had this. I guess everything else is the same, but this is different. I will not do this today because I'm tired, and tomorrow I have to wake up early, and I will do this tomorrow. Yeah, this is also very, very complex. And the planet, well, maybe the planet, I can do it for the planet, because the planet is small. Ooh. I guess the planet is exactly the same thing as the broken part. Because it just needs to have so this stays. Yeah, it's not exactly like so. Enter tree. Let's copy bit by bit. Enter tree. We don't have enter tree. We have ready. So I can put this in ready. paste, and all of this can be this will disappear because this does not exist anymore. And we need to have this copy, paste. And here we just need to, oh, this is a planet, this should be a rigid body, so set freeze is direct. No. Rigid body manager, set freeze. Right here, rigid body manager, set freeze. It's just freeze. Okay. No. Why not? This is a rigid body manager. This freeze is a variable, it's a boolean. This is expecting a boolean. Can, yeah, of course not. Equals to, come on. So yeah, we get the thing, we add this to the gravitational, and we have the constant. If add to camera list, we add to camera list, and if freeze, we freeze. That's it. The planet has polar gravity. Let's see if the planet level works. Maybe it will not work because of the numbers of the spaceship. Orbital turn, no, higher orbit. So the planet, let's build. Okay, the planet has the script. Freeze. It has weight, it doesn't have local force. Okay. And the ship, let's put the same numbers, 100. And here we can just reset this. Maybe more fuel. It is not very important at this point. And that's it. Let's play. Let's see if the, yeah, I forgot the speed. Speed, and let's go like 50. Oh, wait. The planet is not going to the rigid body manager. Make sure the script exists. Of course the script exists, but it has the wrong name, probably. Polar gravity manager, on root. This is okay. So what's your problem? This comes from where? Cannot initiate the script associated because the class cannot be found, blah 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 blah. Yeah, but from where? Which was the thing that asks for this and cannot be? From the planet? I don't know. The spaceship? No, this is a copy paste from the other one, so it should work as the other one. It should work as the other one. So maybe the problem is the planet. I will delete the planet. Delete. Let's see if we have the same errors. No, we only have 2 errors. This is in level progression, okay, no problem, and this is in left panel computer, okay, this errors, no problem. Let's undo. So we have the planet again. This planet is not finding something. Oh yes, because rigid body, delete, polar gravity, delete, save. And the planet has whatever it needs to be to have. Higher orbit, play. Let's put the ship a little bit down so we can deaccelerate in time. Ship, go here. Can we stop in time? We are not falling into the planet. So what's wrong? Spaceship. Oh, forgot to enable the polar gravity on this spaceship. So save, play. But it's not falling. Maybe the planet is not having itself. Oh. Polar gravity manager, yeah, we get it. Add target, this target. We get this constant gravitational constant. We don't need this here, I guess. We're not using this anywhere. If add to the camera, but the camera cares about the camera, and the planet is freezed. Or is the freeze, whatever setting it has, save. If add camera to target list, game events, okay, this is to remove this from the camera. Oh, come on. Of course it's not working. Lol. We don't have the process. So it's not actually processing anything. But technically, the spaceship has. So the spaceship should fall into the planet. Yeah, the planet is not falling, but also not the spaceship. Yeah, the planet doesn't have gravity because this is floating around. Oh, let's find the bug. So these two errors are related with the level manager, game session, no problem, and this is the left panel, also no problem. Let's look at the planet. The planet is a rigid body, yes. It weighs a lot, yes. Or maybe it's not a lot enough, because eventually we'll change to this number, but this should be enough to pull the ship, unless this is extremely big. No, it's not. It's almost the same size as the other one. So if it works on the other one, maybe I have here something. Yeah, maybe this freeze. No, freeze mode static. Yeah, but this does not affect the ship 1. Maybe the problem is on ship 1. So the planet adds itself. Let me check again. Planet. Polar gravity, yeah. Gravity at target. This one. Itself, okay. So the planet is in the list of things that attract each other. Now the spaceship 1 weighs 100. It's not static. It has polar gravity. This is not important. Allow all the engines. I put here a 0, it was an 8, but I guess this doesn't affect anything. Very strange. Why this spaceship falls and the other doesn't? Oh, it's not this one. It's the 2. Okay. 100 as polar is the same numbers. Copy. Delete. Paste. Play. Process visuals. What's wrong? Come on, what's wrong? I don't like when this happens. Undo. So let's check if I change something on the ship script by accident. No, it's still working. This is the same script. I don't know what's happening. Or maybe the planet is not being added correctly, but I'm pretty sure it is. This is a rigid body. It has a sprite in the collision shape. Maybe it's not heavy enough to attract. Yeah, but we should have a tiny bit of movement. Well, the broken part is working, so let's do a stupid test and let's change this script. Broken part. So this no longer is a planet, it's a broken part that waits this 999,999 kilos. Let's go to the scene. Broken part, okay, F6. This is so strange. It's not falling. Let's remove the spaceship and let's add the spaceship again. Ship 1 around here. Why the ship 1 does not exist? Because it's in the wrong canvas layer. Okay. Play. Same 2 bugs. Okay, no problem. So now this ship 1 should be with this rotation around here and should be moving like 50, 40 and should has polar gravity. That's it. Let's remove the planet. Oh, the moon is much heavier. Maybe that's the problem. Maybe not. Undo. I cannot undo. Oh, come on. So, where's the planet again? It's here. Planet 1. Planet 1 waits. Let's add 2 more 9s. And see if the spaceship starts to fall. Well, I guess it's happening. Very slowly, so let's add another 9 here. Okay. I'm orbiting the planet. Yep. This is working. Okay. So, the assignment for today is done. I was having problems with this polar gravity. And I found a solution. My mistake, I was multiplying the delta in the wrong place. And today's assignment was to, or mission or whatever, was to make this polar gravity work with the previous assets, because I tested a new thing that is nothing. It's just the sprite. Now it's actually working. So I'm happy. It's not exactly working as I want, because I want the spaceship to fall. So maybe this planet needs to be just a little bit heavier. Let's go 99. Or maybe I can have a multiplier or something like that. Oh, but I'm using the... I don't have script here. I have the broken part script copying. I want the planet script. Planet 1. Planet script. Planet script here. Yeah, and this is the number. Another 0. Okay, save. Freeze, object mass. Yeah, this number needs to go up there, I guess. Paste. Because I'm not changing the mass, so who cares? But I should, so mass equals mass, maybe. Object mass is object mass. Okay, save. And this should work with this new... It should work with this new script. I'm playing the wrong scene. Play. Okay, I'm following. So it actually works, which is nice. And I'm kind of happy. more or less. This is my happy face. Super happy. Everything started here. Or maybe not. What? Whatever. Everything started started here. And well, everything started with a big mistake. Every time the ship went into a loop, it gained speed, which was wrong. But then I found where was the problem, I solved the problem, and now I have the tools that I need to approaches, to connect and disconnect, to land, to take off from landing, to move, to orbit. Okay, I already have 6 tools, very useful, that will help me a lot making several levels, different levels. So yeah, that's it. This is where we have tomorrow. I will, or maybe I don't know if I stream tomorrow, but tomorrow I will have I will fix the same thing I did for this ship. I will do for the ship lander and the ship top, because these are very big and it will take some time to do it. What I actually want to do is to fix the moon lander and eventually build some new levels, because I'm a little bit tired of the same ones. And this orbit stuff will be the next tool I need to make more levels. So yep, it's orbiting, it's stable, I can control it, I can crash, everything stays in orbit, things react with each other. And I believe the thing is behaving as I was expecting 3 or 4 streams ago. Let's try to go closer to the moon. If you go closer, you go faster, as in real universe. If you go far away, you go slower. Yeah, it's working. So I hope you enjoy this boring, extremely boring stream. Maybe the next ones will not be so boring, because I will pick up all these tools and build new levels, which are more interesting than just fixing code. And for today, I'm done. I have classes tomorrow. Very, very, very early in the morning. So, if you find this interesting, subscribe and like the videos, please. And see you in the future. The credits button is here. Bye bye.